Good afternoon, ladies and gentlemen. Sorry, I cannot be with you today. Um, Unfortunately, I've injured my foot and I've torn some ligaments, and they need, well, at least a week to repair. And obviously, teaching is quite the way I teach is quite a physical job. I walk up and down the classroom, so and I find it just difficult to sit in front of a screen, um, especially when you're all asking me lots of questions. So forgive me that I can't be with you today, but it's really important that we produce this video because you've got an exam soon. I just wanted to go through line of balance, an introduction for this afternoon's lesson, and then I've got a task for you to do, and then maybe tomorrow I'll have another task for you to do in the morning because I don't think Aladdin's going to be in. And then on Thursday I'll have a quantity surveying task and a video a bit like this one for you as well. So I need you to carry on. Obviously, when you've got exams, when you're teaching, you've got to keep the momentum going. And I appreciate myself and Aladdin being off disrupts that um, momentum. Okay, so here we go. Okay, so the lessons on line of balance. If you remember, I talked about it a couple of weeks ago when you had a go at the Task 6 2022 paper, produced a nice Gantt chart, but you were out a little bit with the days. And because it's a repetitive operation, because it's building 6 townhouses, which look very, or 8 townhouses, sorry, which look very similar, and they've capped the number of operatives that you can have on site. If you look at the problem, I think it's 20. I believe that demonstrates that they want you to do not so much a line of balance, but a resource histogram. And resource histograms and line balance are linked. So hence why I've called it a line balance. And I'll show you a line balance, but I don't think you need to worry too much about line balance, but certainly resource histograms. But I've done both in this presentation for you, okay? So basically the aim of the lesson is an introduction to line of balance and labor resource histograms, okay? So if we just move on to the next slide. A line of balance diagram basically comprises, and that's why I always do this, I do this diagonal. Okay, I'm doing it with my left hand. It just seems a bit worse in there because it's coming out with my right hand. A series of inclined lines which represent the rate of working, particularly with regards to repetitive operations. Okay, in a construction sequenced operation. So it was originally developed in manufacturing. However, we've implemented it in construction, particularly house building. All right, because it's repetitive. Anything that's repetitive, one can use. Okay, it's pioneered by Lumsden in 1965, and really it's one of the best planning methods for repetitive work housing, which you've got in this particular scenario, or even refurbishment, provided the refurbishment is a repetitive um, operation, or civil engineering, piling in particular, because you see use of piles, pile caps, beams, floors, etc. So it's really good when we use it in civil engineering as well. So just to sort of let you know where it could be used, I've used it myself in manufacturing, repetitive operations, okay, and it works really effectively. Very good problem solving tool, actually. Looks a bit like that. You can see the diagram on the side. You've got activity A, activity B, activity C. All right. You look at it, when you first look at line of balance, you think, oh my God, what's that? Okay. All right. But you get used to it. It's something that you get used to. So don't let that frighten you. Okay. All right. So it's a bit like a series of bar charts. They're separate, as you can see with bar charts. They don't have to be separate, by the way. And what you're trying to do is get them into balance, get them parallel to one another. And as you can see, C is completely out of balance to A and B. In fact, B is out of balance to A, in fact, okay? But not as much as C is out of balance with B. So if it's a repetitive job, that tells us, if we link it back to lean manufacturing techniques, lean construction, that there's a lot of waste going on there. Our 7 waste, if you remember Tim Wood, Tiger Woods' brother. Okay, so there's something going on with those wastes because it's a repetitive operation. All right, so what that would do, if we could produce that diagram and we can see where we're going wrong, we can use it as the basis of an analysis, because what we want to do really is have A, B, and C in parallel sequence as close as possible. So the buffer zones at the top are not so far apart, you know, because if you look at the buffer zone between A and B, okay, it's much narrower than B and C. What we really want is the buffer zones to be at equidistance, if you like. All right, and that's what we're trying to do. And by trying to do that through a number of mathematical and graphical exercises, will allow us to put it back into balance. Okay. And that's what we want. You can see A, B, and C now back. That's the ideal relationship. You're never going to have that, but that's the ideal that we're looking for. Okay. So if I go back here, if I go back to the previous slide, sorry, won't allow me, but also I'll continue. If you remember in the previous slide, the buffer between A and B was slightly less than B and C. So what we could do, because we got this large buffer with B and C, we could increase the resources required. So we could increase the labor to make the time quicker, so reducing the time. Use maybe a crane. Instead, maybe use a tower crane instead of a telescopic crane. I don't know. You'd have to explore these sorts of things. All right. However, remember, there's only so much labor you can have on site at any one time, so you mustn't exceed a certain labor ceiling. And in the question, for instance, that I'm talking about there, 2022 that you did, the reason that I suggested that it's probably a line of balance labor resource histogram is because they categorically and explicitly say X amount of labor can be on site at any one time. So I think it's 20, but you'd have to check. Okay, so forgive the pun, you have to balance the line of balance against other interests. Economic, you might not be able to afford 100 gangs on site at any one time. You might not be able to afford the tower crane because you might have to have a cheaper option. So you've got to balance all of these things against economics, the physical constraints, the physical size of the site, the shape of the site, the where how is it a rural site? Is it in a city centre? You know, think of the Octagon building that's going up the road. It's in a very, very narrow site. So they would have probably, and it's repetitive, 8 floors, 10 floors, whatever it is. It's a repetitive operation. So they definitely would have used line of balance. They definitely would have used labor resource histograms. Okay. So that is the issue. I just sort of went through the issues there. Is how much labor we can have on site at any one time. If the physical aspect of the site is such that we can only have 20 operatives on that site at any one time, if we have 25, they're going to get in each other's way. So that's going to have a detrimental effect on productivity. So we're always after this sort of line of ceiling, if you like, how many workers we can have on site at any one time, and we mustn't go above that ceiling. You know, how much money have we got? You know, can we afford a tower crane for 4 weeks, or a telescopic crane? Can we afford in the budget a concrete pump, or do we have to employ labourers to sort of wheelbarrow it before placing it? all these things have to be sort of analyzed. So remember, they're in the background, okay? Because we're simplifying it for you, all right? And that's why we would use a resource histogram. And that's why for your task, I would have done a resource histogram beforehand. And although I'm going to show you, line of balance, the exercises are really what you need to do is about a resource histogram. But I just want to show you the relationship between the two so you get this deeper understanding of why we're doing it. So if I just give you a quick task, all right, and I'll talk you through this task, all right? Okay, so it's a repetitive exercise. It's piles. So you're going to install the piles, and then you're going to connect the piles with in situ concrete, reinforced concrete beams, and that needs carpenters, all right, to make the formwork, and then it needs laborers then to pour the concrete properly. Okay, we could have added steel workers to it, but I just want to keep it simple. Once the in situ beams are in, we then put a precast concrete deck. So precast, the concrete deck is made off site, and so we'll need a crane. We'll need a couple of laborers to put it in place, and it'll be quite a quick operation on site. So the two operations that are going to take some time is installing the piles and the in situ beams, in theory. The maximum number of operatives we're allowed on site at any one time during this operation is 15. All right, so we can't have 16, we can't have 17. All right, we can only have 15. Okay, so it's a repetitive operation, as I'll show. If I move on to the next slide, you can see the access deck to the right. Bay 1, Bay 2, Bay 3. Bay 1 has got 4 piles. Then you put your pile caps and your concrete beams, 4 of them. Okay, then you add another 2 piles, and then another 2 piles, another 2 piles, and so on and so forth. So you have this series of bays which are square shaped. Okay, and to finish off, then you put these reinforced precast concrete floor decks in on top, so they're lifted on top, so they only need 2 laborers as such. Okay, so the resources you require for that: pile machines, concrete pumps, because you're going to pump the concrete, crane, okay, 3 operatives for piling, okay, 4 carpenters and 2 laborers for the pile caps and beams, because you've got timber formwork, as well as concrete pouring. Okay, and then you only need 2 laborers then for the floor decks, because one just to sort of indicate to the crane driver where you want the beams, and then just the other one there for health and safety as well, a bit like a banksman, if you like. All right, so that's why they only take 1 day. You can see the biggest operation is 4 days, which are the bays, the concrete, the in situ concrete, which is slow, it's dirty. Okay, but once the carpenters have done 1 set of formwork, that's all they got to do is take it off and then put it onto the next set, and so on and so forth. Or they can just do formwork and put it in place and and the laborers then remove it as they move on. So what I'm saying is the carpenters would put formwork in bay 1, they pour the concrete, and then the carpenters would move on into bay 2, and once after the concrete, and then bay 3, and then the laborers would start stripping out afterwards. So there'd be this continuous operation. But obviously, what you've got to remember, that site is quite constrained physically in a geographical sense, and in a physical sense, it's quite constrained. You're talking about having a large pile machine there, okay, rig. You're talking about which are really large. You're talking about having a crane. You're talking about having concrete pumps with concrete trucks and all this labor. So we have to set it up so that they're not working. They're working together rather than against each other and getting in each other's way. So the sequencing, in many respects, is quite logical. So I've done slightly different. This is slightly different to the book which I based it on. Okay, so I'll show you the answer the book gives you. Mine is 1 day less, because I've added another carpenter, okay, because I think another carpenter is required. So mine is 1 day less than the actual answer, okay, and that's because I've added a carpenter. I'm well within the 15 operative resources, okay. So I've got 3 operatives for the piling, 4 carpenters and 2 labourers for the pile caps and the beams, so that's 6 operatives, and then 2 operatives, 2 labourers for the floor deck. All right, and remember, it's a histogram. A histogram is not a bar chart, okay. It's not a bar chart, so you don't have to have these nice bars in parallel with each other and separate from each other, because it's what's called continuous data. All right, so it would look something like this. There you go. Sorry about. Okay, so it's going to take a total of 28 days. The piling takes first, okay, and so 3 people, okay, 6 piles, sorry, 6 bays. All right, that would take 12 days. Okay, all right, so you would complete 1 set of piles every 2 days. Yeah, all right, so 2, 4. So bay 1 will take 2 days. Bay 2 would take 2 days. So that's 4 days. Bay 3 would take 6. Bay 4 would take 8. Bay 5 would take 10. And bay 6 would take 12. So that's your operation. But once I get to once I've completed 1 bay and I put 4 piles in and I move on to the next bay, it gives me scope then to start my formwork operation. So I can start the operation regarding the pile caps and beams. So I can start that in about 3 or 4 days. I've started at 3, but you might want to start at 4. Okay, I don't think you can start it at 2, because I just think the site is too constrained. So start it at day 3. I need 6 operatives, so 3 operatives. If you look at the vertical scale there, 3 operatives plus 6 gives me 9 operatives, and I'm still way below my cutoff line. If you have a look at the top there, the red line at the top, my cutoff line is 15 operatives, or 15 labourers, 15 labour I've put. Okay, so I then can move over. Okay, it's taking me so many days then to do the pile caps, and once the piling is finished, the labourers that I require for the piling can go away. So it reduces my labour on site, hence the drop in the histogram there, okay, at day 12. All right. And what I worked out then, to complete the remaining, takes up to 27 days to do the pile cap operation with 6 operatives. That's 4 carpenters and 2 labourers. Because with the pile cap operation and the decking, with the pile cap operation, I'm going to need a concrete pump. I'm going to need labour. There'll be vehicles back and forth with the concrete. So that's going to take up a lot of my space. So I don't think I can start the decking, because the decking is precast concrete. It's been manufactured off site, brought onto site, and then once it's brought onto site, it's unloaded using a big crane, because that takes up a lot of physical space. I don't think I can start my decking. The earliest I can start my decking, I think, is 22 days. Whilst the carpenters and the labourers, the 6 carpenters and labourers, are finishing off the pile caps and in situ concrete beams. So they'll be on about bay 5, bay 6. So you could start the decking of bay 1 at that stage, because you can start at the other side of the site. There's an argument you could start earlier, but I've put it there, okay. And it's only 2 labourers, so it takes me from 6 to 8. So I'm still 7 labourers below my target of 15. And then at the end, I finish my pile caps and in situ beams. The formwork has been taken away, and I'm doing my final bay, which will only take me 1 more day. Yeah, 1 more day, 27 to 28. So if you have a look at that little yellow thing there, and the word deck at the bottom there, so it reduces quite dramatically to two operatives for the last day. And that's it. That's quite economical. It takes me about 28 days. All right. And The operations, if you think of a Gantt chart now, the operations, some operations, or all three operations are running concurrently. Okay, so you don't finish one, you don't finish one and then start the other, like a lot of you got. You can run them concurrently. The bars will be concurrent. You don't run them at the same time, but you can run them at the same time as long as one starts after the other, and you can time when the other one needs to start and how they all sequence together. I hope that makes sort of sense. All right, I'll give you the answer they got in the book. Remember, they're using different maths to me, so they've got 29 days, okay? And I'll show you how it works with a line of balance, okay? So the line of balance is at the top, and they've got 29 days if you have a look. It's very similar to mine, okay? However, the line of balance demonstrates that the pile cap and beam is out of balance. So what can I do? And if I went back to my previous slide, you could see that I still had scope. You know, the most I do is 9 operatives on site at any one time. That's the maximum I've got if I follow that pattern. So I've got room for another team of operatives, another 6 operatives. So if I bring in another 6 operatives, only for the pile cap and the beams, that's another 4 carpenters with support from 2 labourers. There's an argument I can reduce that considerably, because I would put that pile cap and beam line into balance. So at the moment, sorry, if I can't because the camera the way. So it's like this at the moment, and I can just take it up so it's like that. And what I'll do is move that across from 29 days, hopefully down to around 18 to 20 days. So I'm reducing the operation by about 10 days, maybe at max. I hope that makes sort of sense. I'm not there to take questions, so I do apologize. So look, the pile caps are out of balance, and only if it's economically feasible, we can double the gang of the pile caps and in situ concrete beam construction process, because we have a maximum on site of 15 labourers. We're not fully utilising the space that we've got, the scope. Furthermore, once 2 bays have been completed with regards to the piling operation, then it'll give us that room for those extra gangs and the extra resources that they're going to require without them getting in the way of each other. So look, let's increase the labour just for the cap and beam, okay? The pile caps and the in situ concrete beam. All right, so we're going to add another 6 operatives, and this is what it'll look like. All right, look, I've got up to my 15. I've got to be careful, I can't go above it, you know? Less than or equal to 15 operatives, it says, okay? But look now, everything now on that graph looks more vertical than horizontal. And I've managed to do it. See, I've got space for the deck. If you have a look, I've got space for the deck. I could take that another day if I wanted to. So I could take another day off. I just felt I couldn't do it because there would just be too many people working on site at any one time. But there's an argument that counters my argument there, okay? So I could have reduced it to 18 days. It's actually taken me 19 days. So I've reduced it up to, so I've reduced my time now by 9 days. The operations now are much more efficient. Therefore, I'm going to be saving myself money because productivity is going to be much higher. All right, so piling is still the same. It's just the cap and beam now. We've doubled it. Gang 1, gang 2. And then we got the decking, the split again over the days. And again, we could draw or we could produce a Gantt chart based on that. Yeah, okay, with resources added to it now, because we know now exactly what we require. So, and then if I show the relationship, so I'm going to go back to the book and I'm going to show you the relationship and how it goes into balance. Okay, there you go. Now you can see it's much more in balance. So the buffer's at the top of the chart, not so much at the bottom with the scale is, okay, the day scale at the bottom, the horizontal scale. It's at the top. The buffers now are just 1 day, or 1 day for operation 1 and 2, or A and B if you like, and then 2 days. The buffer at the top is for 2 days then at the top there between the pile caps and the decking. Okay, the beams and the decking. So you can see they're still slightly out of sync, but they're much closer together. They're, 1 day for one and two. The buffer is 1 day for one, and the buffer is 2 days for the other. That's much more efficient. And financially, as a quantity surveyor, to be honest with you, if it's much more efficient, it's going to be, in the long run, less costly. And therefore, if it's less costly, it's going to be more profitable, one would argue. Okay? All right, because I could bring cost into this as well and show you that as well. I don't want to make it too complicated. All right, so I hope that quick presentation of 30 minutes was okay. All right, so look, the operatives are in balance. You do not exceed the 15. You get to it. You get to that point. I know. All right, but that's fine. That's what you've got. It's the most economical way. And more importantly, well, not more importantly, because you want economics is so important, it's leaner. It's reduced over 8 wastes. Okay, all right, of tin woods. Okay, time in this particular instance. Okay, but there are other wastes will be in that'll contribute. And if I wanted to do something like a value added, okay, I could, as a quantity surveyor, I could do a value added sort of analysis, just in case the cost was a little bit more, but I could show how, by value engineering and using value engineering techniques, I could show where you are making the savings, and in the long run where the profit is going to be. All right, so it's just not just about planning engineering, it's also about quantity surveying. All right, so I hope you found that straightforward, because I'm not there to answer questions. I will be back next week, I promise. So what I want you to do, and I've uploaded it onto Canvas, or I'm about to actually, once I finished this presentation. I'll put this presentation should be on Canvas as well. Go back to that 2022 paper, the one where you completed the Gantt charts with myself and then Ali and Aladdin, the three of us. And what I want you to do is, I don't want you to do a line of balance because it's not asking for that. Before you produce that Gantt chart, produce a histogram, a resource histogram. Try your best. Look at mine. Look at it. Try your best. Remember, I think it's 20 operatives. You can't go over 20 operatives, so you've got to move on. And then from that histogram, produce your Gantt chart and see if it reduces the time in any way, even if it's a couple of weeks. All right, it's still going to be cheaper. All right, it's still going to be cheaper. Try that. It's task 6. It is okay. I think I've put all the I will be putting all the tasks online for you now. All right, thank you so much. Apologize once again. Email me. I'm out. I've got my daughter this afternoon. I won't be able to email you straight away back, but if you want to email me, I'll be able to answer them maybe tonight or something. All right, cheers guys.